All right, today we're going to pull back the curtain on a really cool secret in mathematics. It's this hidden bridge, this secret shortcut that connects a super difficult problem with a surprisingly simple solution. So, let's start with the hard part. Here we go. Take a look at this. This is the beta function, and it's defined by this pretty intense-looking integral. And, if you're looking at that and thinking, whoa, that looks like a real pain to solve, you would be absolutely right. Trying to work through that integral directly, it's not easy at all. So yeah, that's the big question, isn't it? Where would you even start? Do you just have to grind through all that calculus? Or is there another way? Well, it turns out there is.
So let's get formally introduced to our challenge for today, the beta function.
Okay, so the main thing to get here is that while we have this perfectly good definition, actually using it, solving that integral for different numbers, can just take forever. There's got to be a better way. And the solution, the better way, comes from a place you might not expect. It comes from an ally called the gamma function. Now, don't let the fancy name fool you. The gamma function is basically a bigger, cooler version of the factorial. And for any positive whole number n, the rule is incredibly simple. Gamma of n is just n minus 1 factorial. That's it. We're talking basic arithmetic, not complicated calculus. So much friendlier, right? And this just lays it all out perfectly. On the left, you've got our challenge, that messy integral. And on the right, our ally, nice, clean, simple factorials. I mean, they look like they're from two completely different mathematical universes. So, how do we get them to talk to each other?
So what is the link? How do these two connect? Well, this is the secret sauce. This is the bridge that connects those two worlds.
And here it is. This is the shortcut. The beta function of x and y is just the gamma of x times the gamma of y, all divided by the gamma of x plus y. That's our bridge. It lets us completely bypass that difficult integral and just play with some simple numbers instead. And let me be clear, this isn't just some minor little trick. This identity is a huge deal in its field. It's a cornerstone that ties these two major functions together, and it lets us understand both of them in a much deeper way.
Okay, enough talk. Theory is one thing, but let's actually see this thing work. Let's put the shortcut to the test.
So we're going to try and solve for beta of 3, 2. So that means our x is 3 and our y is 2. Let's see what happens. So we've got two paths we can take. Path 1 is the hard way. We plug the numbers into that integral and wrestle with the calculus. Path 2 is our new shortcut. We use the gamma function relationship and just deal with factorials. Let's see which one we like better. And boom! Here are the results. If you go the integral route, you multiply everything out, you do the integration, you plug in the numbers, and you get 1/12. Now look at the gamma method. It's just 2 factorial times 1 factorial divided by 4 factorial. That's just 2 divided by 24, which is also 1/12. Same exact answer. Look at that, 1/12. It's perfect. One path involved a bunch of calculus. The other was just simple arithmetic. But they both got us to the exact same place. That right there is the power of this secret connection. It's just awesome. But this is really about more than just dodging a difficult integral. The connection itself has a much deeper meaning. So why does this relationship really, truly matter? Well, there are 3 really big reasons. First, obviously, it makes things way easier, like we just saw. Second, it actually lets us use the beta function for more numbers. The gamma function works in places where that original integral breaks down, so this formula expands what the beta function can do. And third, this identity is a key piece of the puzzle for figuring out other really famous results in math, like the fact that gamma of 1/2 is the square root of pi. And that pretty much wraps it up. It really makes you wonder, doesn't it? Math is just full of these beautiful, elegant, hidden connections. The one between the beta and gamma functions is a perfect example of how two things that seem totally unrelated can be linked in a way that turns something really complex into something beautifully simple. What other shortcuts are just out there, waiting for us to find them?